Hi, I'm Andy, and this is my lesson on some advanced Boolean expression techniques in Java. In this lesson, I'll explain an important concept when writing and evaluating Boolean expressions, called short-circuiting. Then I'll show you how you can simplify some Boolean expressions using De Morgan's laws. Let's get started. Suppose we have this small program that asks for two numbers, one which we'll store in a variable called num, and the other which will be stored in a variable called possible factor. The purpose of this program is to check to see if possible factor is a factor of num. To do that, we'll add a Boolean variable called isFactor, like this. Now to check to see if a number is a factor of another number, we'll use the modulo operator to find the remainder of a division operation. If that remainder is 0, we know it is indeed a factor. Let's run our program for both possible cases. So it works. When the second number was a factor, isFactor was true. When it wasn't a factor, isFactor was false. But let's see what happens when I try to check to see if 0 is a factor of a number. It looks like we got an arithmetic exception because while finding the remainder, we divided our number by 0. Exceptions are bad. They indicate that the program crashed while someone was using it. We need to avoid that if at all possible. We can eliminate the exception by adding a check to see if possible factor is 0, like this. Let's run our program again and see if it works better now. Notice our program did not crash and we got the correct result for isFactor. But why didn't we get an exception this time? Doesn't this expression still cause division by 0? No, it doesn't, because of a concept known as short-circuiting. When this Boolean expression is evaluated, only the first expression, this one, is evaluated initially. If this one turns out to be false, which it does when we enter a possible factor of 0, there is no need to evaluate the second expression. Java is smart enough to know that if the first statement in an AND expression is false, the whole thing will evaluate to false. So in that case, it doesn't even bother evaluating this second expression. That's what we mean by short-circuiting. That means the division here never happens when we enter 0, and thus we never get that arithmetic exception. OR expressions do the same thing, except they short-circuit, meaning they quit evaluating, if the first statement is true. Because if that one is true, the entire expression is true, and the second statement does not need to be evaluated. Okay, so that's short-circuiting. It's a clever way of preventing unnecessary program crashes due to exceptions. Now let's shift gears a bit. Suppose you have this complicated expression and you want to simplify it. Whenever you have an expression with a negation symbol out front, you can simplify it using a little trick called De Morgan's laws. These basically say that you can rewrite any logical expression like this by distributing the negation symbol, kind of like you would do with math expressions. Here's what I mean. I'm going to distribute this negation symbol by applying it to each and every relational and logical operator in the parentheses, using the phrase "the opposite of" to help me out. So the opposite of greater than is less than or equal to. And the opposite of and is or. And the opposite of less than or equal to is greater than. And the opposite of or is and. Lastly, the opposite of a negation symbol is simply nothing. Two negation symbols simply cancel out. These two expressions are equivalent, meaning they will always produce the same Boolean value. De Morgan's laws are helpful for determining if two Boolean expressions are equivalent, or, as in this case, for slightly simplifying a Boolean expression by getting rid of a leading negation symbol. And that wraps up this lesson on short-circuiting and De Morgan's laws. I'm Andy. Thanks for watching and coding with me today.